All right, this is 7.4, my math lab. We're going to start with square root of 12 minus the square root of 75. And what we're going to want to do is you can either kind of list out perfect squares and try to see, can I divide 12 by any of those? Can I divide 75 by any of those? Or just start your factor tree wherever you want. 12, the only perfect square I see is 4, right? I know 12 can be 4 and 3. 4 is the perfect square of 2 times 2, right? And 3 is a prime. So it's actually the square root of 2 times 2 times 3. These come out. So that translates to 2 square root of 3. The square root of 75, I know I can take 75 and divide it by 25. So 75 becomes 3 and 25. 3 is still 3. 25 is 5 times 5. So we have the square root of 3 times 5 times 5. The 2 5s come out. And we have 5 square root 3. Need to bring down that minus sign. So we have 2 square root of 3 minus 5 square root of 3. Now, if you have the same number under the radical, you just subtract 2 minus 5 is negative 3 square root 3 as our final answer. Number 2 is 4 times the square root of 2x to the third plus 6x times the square root of 8x. We're doing the exact same thing. So 2x to the third. 2 is a prime number and it's not a perfect square, but x to the third, right? That makes 3 x's. So I can take these two out and I'm left with 2x under the radical, right? And I have an x out here now. And I'm going to bring down that 4. The 4 just came straight down. Good. Now I have plus 6x, 8 can be 2 times 2 times 2, right? And 1x. These two 2's can come out. So that's now 6x times 2 times the square root of 2x. Is that all right? 6x times 2 is just 12x. Square root 2x. Bring down that plus sign. 4x times the square root of 2x. Now they have the same number under the radical. 4 and 12 is 16x. And then leave that radical the same. Radical 2x. Same with number 3. We're just going to be simplifying however we can. And hopefully we end up with some terms that are the same under the radical so we can combine those because those become like terms. Right now they are not like terms because the radical is different for each one. 48. Can I divide it by 36? No. Can I divide it by 25? No. 48 divided by 16. 48 divided by 16 is 8. Yay. Okay. Oops, sorry, that was 16. 48 divided by 16 is 3. 48 divided by 8 is 6. 48 divided by 16 is 3. So I'm going to take that 48 and call it 3 and 16, right? Okay. 16 becomes 4 times 4. 3 remains 3. So I have 3 times 4 times 4. The 4's come out and I have 5 times 4 times the square root of 3. 5 times 4 is just 20. Good. Now, hopefully, if I divide 32 by 3, I get a perfect square because then I can leave that 3 inside, right? So 32 divided by 3 is no. Sorry, you couldn't see that. Okay, 32. Can I divide it by 4? Can I divide it by 9? Can I divide it by 16? Can I divide it by 25? 32 divided by 16 is 2. Good. So 32 becomes 16 and 2. 16 becomes 4 and 4, and 2 remains 2. So now I have negative 2 times the square root of 4 times 4 times 2. Those fours come out. -2 times 4 is -8. Square root 2. Good. So now I have 20 square root of 3 minus 8 square root of 2, 27. 27 is not a perfect square. Can I divide it by 9? Yes, I can. 27 divided by 9 is 3. So 27 becomes 3 times 9. 9 times 9 becomes 3 times 3. So that becomes 3 square root 3. Okay, so I'm going to write it all down here. 20 square root of 3 minus 8 square root of 2 plus 3 square root of 3. 20 plus 3, those are like terms because they both have a square root of 3. 20 plus 3 is 23. Leave the radical the same, minus 8 radical 2, because that is a different radical. These two cannot be combined, so that would be the simplest form. All right, now we have cubes, perfect cubes. Let's look at our options for perfect cubes. We have 8, 27, 64, and 125. For 24, it looks like I can take 24 and divide by 8, right? So 24 becomes 8 times 3, right? And then 8 as a perfect square is 2, or perfect cube is 2 times 2 times 2. 3 stays the same. Now that 2 can come out. So I have 2 cubed root 3, what was left over, and then we also had the x left over, right? So that's the simplification of the cubed root of 24x is 2 times the cubed root of 3x minus, right? And then 192. 192 divided by what? 192 divided by 64, maybe? 3. Good. 192 becomes 3 and 64 and x, right? 64 is actually 8 times 4. X is just x. 3 is just 3, so that stays 3. 8 becomes 4 and 2. Sorry, 64. I apologize. 64 becomes 16 and 4. 16 becomes 4 times 4. 4 stays the same. And x comes down. So now I have 3 4s that I can take out, just like I have 3 2s over here. So that becomes 4 times the cubed root of 3x. That's what's left over. That's a minus sign. So I have 2 minus 4 is -2 times the cubed root of 3x. 5 square root of 9 minus 3 plus square root of 3. The square root of 9 is actually 3, right? 9 is 3 times 3. So that's 5 times 3 minus 3 plus the square root of 3. 5 times 3 is 15 minus 3 plus the square root of 3. 15 minus 3 is 12 plus square root of 3. All right, 6 is 8 times the square root of 125 minus 3 times the square root of 8 minus 6 times the square root of 45. 125 we can divide by 25, right? It's 25 times 5. 25 becomes 5 times 5, and 5 remains 5. So that becomes 8 times the 5 we're taking out. But remember, because it's a square root, we're only taking out 2 of the 5s, and we're leaving 1 inside. Good. 8 times 5 becomes 40 square root of 5. Okay. -3 square root of 8. 8 is just 2 times 4, but 2 times 4, 4 is 2 times 2. So I can say minus 3 times 2 square root of 2, which is minus 6 square root of 2. And here we have 6 square root of 45. 45, I can divide by 9 and 5, right? 9 becomes 3 and 3. 5 stays as 5. The square root, oh, sorry, the 3 comes out. So now I have minus 6 times 3, square root of 5. 6 times 3 is 18. Square root of 5. Good. Now, the only ones that I can combine as like terms are 40 x square root of 5 minus 18 square root of 5. 40 minus 18, what's it going to be? 40 minus 18 is 22. So now I have 22 square root of 5 minus 6 square root of 2. Or you could say negative 6 square root of 2 plus 22 square root of 5, doesn't matter. All right, let's look at number 7. Number 7 is negative 2 cubed root 625 plus cubed root 40. So I want to look at 625 and determine whether it's a perfect cube. I guess I didn't do. Nine cubed is 729. So I know it is not a perfect cube, right? And now I want to start dividing it by these perfect cubes to see which one it is divisible by, okay? So we'll just put in like 625 divided by, and the top one is 512, right? And then you'll do that again with 343 until you find the one that is divisible by. It's going to be 625 divided by 125 is 5. So 625 becomes 125 and 5. 125 is the perfect square of perfect cube of 5. So it's actually 5, 5, 5, and 5. We only need 3 to remove it, right? So now we have negative 2 times 5 times the square root of 5, cubed root of 5, I apologize, plus 40. If I take 40 and I divide it by 5, it's going to be 8, which is a perfect cube of 2. So 40 becomes 8 and 5, or 2 times 2 times 2 times 5. So that means 2 cubed root 5. I have negative 10 cubed root 5, sorry, plus 2 cubed root 5. Negative 10 plus 2 is negative 8 cubed root 5. Okay, this is the same thing. So we have 12 squared. 12 is 3 and 4. Y is Y. 4 is 2 and 2, right? So that means under this radical, I actually have 3 times 2 times 2 times y. Outside the radical, I have 3y. These 2 come out. So now I have 3 times those 2 are 6y. And then 3y stay under the radical, plus 9, 75y cubed. 75 is 25 and 3, right? And then y cubed is 3y's. 25 becomes 5 and 5 and 3 and y and y and y. Now I'm looking for pairs. Right? So now the 5 comes out. There's a 9 over here from up there. The 5 comes out. The y comes out. The 3 stays in. The y stays in. 9 times 5 is 45 y cubed root 3y. So 45y and 6y is going to be 51y square root 3y. All right, number 9 looks like this. 448, we can try dividing by 216 because 216 is 6 cubed. Nope. We can try dividing it by 125, won't work. We could try dividing it by 64. 448 divided by 64 because 64 is 4 cubed. We get 7, yay. Okay, so 448 becomes 64 and 7. X just remains X. Y is 3y. Okay, I know that 64 is 4 cubed, so I'm just going to call that 4. Under the radical, I'm going to leave the 7. Under the radical, I'm going to leave the x. All 3 of the y's become y. Sorry, I didn't leave room for y. Sorry, y. So it's actually 4y cube root 7x, okay? Here we have minus 3 cube root 56x y to the third. I'm looking at this list. 56 is not on it. I might be able to divide 56 divided by 27. No. 56 divided by 8. Yes, 7. So 56 becomes 7 times 8. That x, those 3 y's. 8 we know is 2. So now we're going to say negative 3 times 2. Take those y's this time. We still have the 7 and the x under here. Okay. Negative 3 times 2 is negative 6y. 7x. Good. Plus y cubed root 7x. Okay, so now I can combine them. 4y cubed root, is it? Or was it not? Yeah, sorry, they're all supposed to be cubed. I did write it up there. They're supposed to be cubed. All right, cube root 7x. So those are all the same radical because the 3 is the same and the 7x is the same. It's very important that both of those terms are the same. So now we can just say 4y minus 6y is negative 2y cubed root 7x plus y cubed root 7x. Negative 2 plus y is just negative y cubed root 7x. Number 10 looks a little different because this is a cubed root. These are square roots. So if this is just to show you that only these two are like terms. The first one is not a like term. So we're just gonna leave the first one alone. 3 times the cubed root of 7 plus, sorry, it's actually gonna be minus because 6 minus 8 is negative 2 square root 7. That's the simplest form for number 10. Number 11, we're just going to distribute that square root of 10 to the square root of 3 and the square root of 11. So we get the square root of 10 times 11 plus the square root of 10 times 3. 10 times 11 is 110. Sorry, the square root of 110 plus the square root of 30. And then simplify this if you can. So 110, can we divide it by anything? We can divide it by 110 divided by 64, no. 49, no. 36. 25, no. 16, no. 110 divided by 9. 110 divided by 4, no. So that's a prime. And then the square root of 30 is, I can divide it by 9. Cannot divide it by 9. Divided by 3. 30 divided by 4, no. Divided by 9, no. Divided by 16, no. Divided by 25, no. So those are both prime, so we're done. Square root of 10, square root of 110, and the square root of 30 for number 11. Number 12 looks like this, the square root of 6 minus the square root of 7 squared. So that means we're taking the square root of 6 minus the square root of 7 and multiplying it by the square root of 6 minus the square root of 7. Good. This times this is going to give me this. This times this is going to give me negative. 7 times 6 is 42, right? This times this is again square root of 42. And then negative 7 times the negative square root of 7 is 7. So I can combine 6 and 7. I get 13. And then this is 1 square root of 42 minus another square root of 42. So that's minus 2 square roots of 42 for number 12. 13 is the square root of 5x times the square root of 5 minus the square root of x. So we're just going to take that 5x and distribute it. So the square root of 5x times 5 minus the square root of 5x times x. So basically we're saying 5 times x times 5, 5 times x times x. Okay, we're still looking for pairs. So this has a pair of 5s. So the 5s come out and we're just square root of x. Here we have a pair of x's. So the x's come out and we're left with the square root of 5. Number 14, we're just going to distribute. FOIL, if you will. So 4 square root of x times 4 square root of x, we multiply those numbers and then we multiply what's under the radical. So the 2 4 stayed outside, the 2 x's stayed inside. Outside, 4 times 2. Multiply the outside numbers, the regular numbers by the regular numbers, and leave the radical to be multiplied with other radicals. Inside, -5 times 4 square root of x. And last, we have -5 times +2. 5 times 2 is 10, right? So 4 times 4 is 16. Square root of x squared. 4 times 2 is 8. Square root of x. 5 times 4 is 20. Square root of x minus 10. X squared, the square root of x squared means x, right? Because those cancel each other out. 2 x's come out. Plus 8x minus 20 square root of x. So 8, because these are like terms, 8 minus 20 is -12 square root of x minus 10. Number 15 is 6 distributed to the square root of 7 and to -2 becomes 6 square root of 7 minus 6 times 2 is 12. 16 is the square root of 10 distributed to the square root of 10, and y is the square root of 30. So this is the square root of 10 times 10 plus y times the square root of 30 times 10. Good. If I have 2 10s under the radical, they come out, right? 10 times 10 is 100. The square root of 100 is 10. Plus y square root 300, right? We know that 300 becomes 103. 100 becomes 10 and 10. 3 remains 3. That'll be y times 10 square root of 3, right? Or 10y square root of 3. We were adding them, and this was just the number 10. For number 17, again, you want to just keep the radicals with the radicals when you're multiplying and the normal numbers with the normal numbers, for lack of a better term for them. So 2 square root of 3 times the square root of 3 we're foiling is 2 times the square root of 3 times 3. Outside is going to be plus 2 times the square root of 3 times 7. Inside is going to be minus 3 times the square root of 3 times 7. Minus 3 times the square root of 7 times 7. All right, let's simplify this. 3 times 3 comes out, so that's 2 times 3 plus 2 times 7 times 3 is 20. Sorry. 7 times 3 is 21. Sorry, like I knew that, but I wanted when I say things wrong and don't catch it, like it's upsetting. Minus 3 times that same term, 21, minus 3 times 7, right? Because 7 times 7 is the square root of 7. Can I take 21 and divide it by 4, 9, 16? No, right? So I have 2 times 3 is 6. 2 minus 3 is minus square root of 21. And then -3 times 7 is minus 21. So 6 minus 21 is 15. 6 minus 21 is -15. -15 minus square root of 21. All right, question 18 is actually about conjugates. So the conjugate of the square root of u minus t is the square root of u plus t. So we have a minus b, a plus b to find the conjugate. So the square root of u times the square root of u is the square root of u times u. Square root of u times t is plus t square root of u minus t square root of u. Negative t times positive t is minus t squared, right? U times u become a u plus t square root u minus t square root u. Those actually cancel each other out. That's why they're called the conjugate. Minus t squared or negative t squared plus u. Doesn't matter. Okay, 9 is asking us to solve square root of 7 plus x squared, which becomes square root of 7 plus x times itself. This is not a conjugate. This is not going to cancel anything out in the middle. 7, square root of 7 times the square root of 7 is the square root of 7 times 7. Square root of 7 times x is plus x square root of 7 plus x square root of 7, right? And then x times x is plus x squared. Those two become 7. This becomes 2x square root 7 plus x squared. Number 20. We have the cube root of 36 times 6. So that's the cube root of 36 times 6 minus 2 cube root 36 plus 3 cube root 6 minus 6. Good. 36 times 6 is 216. 6 cubed is 216. So this is the same as 6, right? Minus 2 cubed root 36 plus 3 cubed root 6 minus 6. 6 minus 6 is 0. So we have negative 2 cubed root 36 plus 3 cubed root 6 as our final answer.